So the demo that I'm going to show you, I'm actually going to show you two use cases. One's a simple one that's just going to take a static big pile of data, process it, and then export it to a database and show the results within Grafana. And that's like an intro case. And then we'll look at a more advanced scenario where we actually look at how you would actually put this into a production setting, because we will parameterize a couple of the settings so that we can just deploy this, deploy NannyML once and have it run on a certain schedule to basically repeat this process day by day and deliver you these time series that are continuously building up. So what does the demo setup look like? We'll be running NannyML as a container. NannyML can be just it's on the Docker Hub, so you can easily find that there and use it. And what we're going to do is we'll run NannyML. We will mount a couple of directories on it. That should make sure that we can have access to the data that we have prepared. We will also mount a store location here. And that's basically going to make sure that we have the pre-fitted calculators available for our repeat runs. The NannyML container is going to run, crunch some numbers, and the results are going to be exported to Postgres, and we'll connect Grafana to that one as well. And we can then visualize all of our stuff within Grafana. And that's basically the scope of the demo that I'm going to show you. If you're following along with the examples on GitHub as well, I think the first one we're going to take a peek at is the multi-class classification one. And let me quickly share another window now. I have a terminal open here. All right. So I hope everything is good and legible. But if we take a quick peek at what you can see within this directory, so we're now in the multi-class classification directory. You can see a couple of different things here. There's a README file, which is a quite verbose description of everything that I'm basically going to tell you here, with lots of commands that you can execute yourself and have a try out. There's a lot of things here that are due to provisioning stuff. So we're running everything as Docker containers, and we're orchestrating them using the lightweight Docker Compose way. We are provisioning a database, and in order to do so, you can see that we have a data definition script here. So within our database, we are going to create a NannyML user and create an additional database that will allow us to store our information there. We are also provisioning provisioning Grafana, and for those interested, you can actually provision quite a lot of Grafana stuff, including some dashboards and data sources. Maybe it makes sense to take a quick peek at the data sources. So if you take a look here, then you can see that we are defining a single data source called NannyML. It's a Postgres database. The URL here is actually an internal container URL because we're running within Docker Compose. So the URL here, or the database host, is called metric store. We're connecting as user NannyML using the passwords that we gave earlier. And that should allow us to seamlessly connect to the metrics database that we have configured. And then we come to the good stuff. So let's take a quick peek at what the actual Docker Compose is looking like. You can tell that this is already a bit bigger. There's three big blocks here. We have a metric store, we have Grafana. So this is basically the database. We are mounting this SQL data definition scripts into a fixed location that'll make sure that the SQL script is executed upon the container starts. Then we have Grafana in here. You can see that we are controlling the user creation here. by providing a couple of environment variables, and also by, again, doing the same trick. We are mounting a certain directory into a fixed location. Hence, Grafana knows to provision stuff for us. And then, of course, we come down to NannyML. You can see that in here, I'm waiting until both the metric store and Grafana are up and running, because otherwise it gets a bit messy in the logs. So this is like more for oversight than anything else. We are using NannyML version 0.8.2. This is the Docker container name or the image name that you can just pull from Docker Hub. And what we're going to do next is also mount a couple of things. So you can see in here that we are mounting something called config /nannyml. And this is basically the configuration file that controls how NannyML will behave in production, right? So this allows us to fully configure NannyML. We are going to mount a data repository. And as I said earlier, like within the overview picture, we're going to mount a couple of directories that allow us to basically see what is going on or provide external data to this container. And the same thing for the store, of course. And as soon as we have started the container, we're going to provide the command that we're actually going to run, which is NannyML run. This is executed by default, by the way, through the container. And now there's one final piece to the puzzle that we are left to check out. And this is the most interesting part, which is the actual configuration file for NannyML. So everything that you saw in code within the snippet that I showed before, that can actually also be used or be configured here within the configuration file. We have a good chunk of documentation dedicated to this one as well, so you should be able to figure all of it out, but let me quickly walk you through it. So you can see there's a couple of big sections here. The first ones are all related to the actual data that we have. So the input data definitions are going to be the reference data, analysis data, and optionally target data as well. It's not required, but in our case, because of demo purposes, obviously, we have it, and we can use it. Now you can see that these are just like regular paths, but you can see in the documentation as well that these might actually be S3 locations. They could be Google Cloud storage locations, Azure Blob storage locations. And in that case, you can add credentials as well. So an access key and a secret, for example, in the case of S3. Or if you have them configured on your workstation, as most of you probably have, using environment variables, etc., then NannyML should normally pick those up as well, if you're running it locally, of course. Within a container, that's a different piece of work. So most of the time, you'll have to actually provide them there. But you might also do it using environment variables in the container. Next up is the outputs. So in here, you can tell that we are using a connection string to the database again. We're providing a model name as well. This is just for table generations within the database itself. It's not a requirement, but I'm just doing it because it's nice. Then we define what kind of problem we're trying to solve here. So this is a multi-class classification problem that has to do with credit cards. We are going to chunk on a daily basis. So I'll not go into details too much, but basically the chunking is going to control the way that your data gets grouped when or aggregated when we're calculating the metrics, right? When we're evaluating metrics. And here we also define how and where we would like our calculators that are fitted to be stored and then reused later, of course. And one of the most important things here is the actual column mapping. Normally, when using NannyML within regular code, you can just provide all of the columns that you need in order to build a calculator or to initialize one. But in this case, because everything is automatic, we actually need a full list of all of these things up front. And you can see here that we just define what the features are for a model. This might be a long list. We're aware of that. Where optionally what the timestamp column might be, and then where we can find the predictions, where we can find the model scores or the model outputs. And this for every one of the classes. Remember, we're dealing with a multi-class model here, multi-class classification, and for each class within the model, we can find a column here, as well as the target values. The target values are always available within reference data as well. Now, that concludes all of the setup that we have. So then we can just do the magical thing and basically just run Docker Compose up. You'll see a lot of output spewing by. So there we go. This is Grafana booting up. It's quite verbose. We also have the database starting in the background. In a second, you'll see it stopping right now. And then we can see NannyML firing up. So interesting to see is it shows us that we're using a database writer. It could not find a fitted calculator in the store, so it's just going to create a new one and fit it. So that's what's happening now. This is normally quite compute intensive, which is also why we try to skip it by storing the calculator. And you can see that it has actually done that right now. So if we were to do a repeat run of this, you would actually see that NannyML will just use the pre-fitted calculator that has been stored within our local directory. You can see that the results of our calculations are being written into the database. I'm afraid we won't have time to go through the whole thing as well, but within the README of the examples, you will be able to see all of the commands that you can use in order to connect to the database that we are also hosting as a container, and explore the tables at your own leisure. Now that we've done that, we can see that NannyML has successfully exited, so exited with code 0, indicating that everything ran as it should have. I'm not gonna shut this down yet because let's quickly swap screens again and go into our browser, because now if we go to localhost 3000 and log in using NannyML, and you can see that we are arriving at our self-hosted Grafana. And we actually have a couple of demo dashboards prepared here. So this is, for example, a view of the drift metrics that we have. So you can tell here we can select, well, in case we were to have like different models being stored within the metrics store, we would be able to select them here. You can select which columns that you want to see the drift scores for. You can select, for example, a couple of different measurements or methods that we use for the, calculating the drift scores, etc. In our case, like Jensen Shannon is nice because it deals with both continuous and categorical values. So in here, you can see that the values are fluctuating quite a bit. And as expected with univariate covariate shift testing, you can see that a lot of the time, like just, they're not random, obviously, but like these one-off events occur where there's a little bit of an alert going on. And this might occur, but you can tell, like in the end here, there is a significant increase in drift score. And you would ideally then use Grafana to set up the alerts to trigger after, for example, like 5 consecutive alerts occurring, right? And this could allow you to then send a notification to, for example, Slack, etc., and automate a workflow based on this information. As a second part of the dashboard, we also have the performance. Again, this is the same kind of information. So you can see here that the realized performance, because we actually have target values, so it was calculated. You can see that the realized performance takes a serious dip after a point in time, and that it's basically moving without or outside of the boundaries, the thresholds that have been set during the reference periods. And that is why we are also getting alerts notifications here. Right. So this is the case like where we calculate everything up front. That serves as a good introduction here, but let me quickly swap back over to my other window. Here we go.